An arithmetic sequence of positive integers has n terms where n is greater than or equal to 3, initial term a, and common difference d, which is greater than 1. Carl wrote down all the terms in the sequence correctly, except for one term, which was off by 1. The sum of the terms he wrote down was 222. What is a plus d plus n? So the first thing we should immediately notice is that because one term was off by 1, we therefore know that the correct sum has to equal either 221 or 223. So let's try to write down the sum of this arithmetic sequence in terms of a, d, and n and see what we can obtain. So the first term is a, the next term is a plus d, term after that is a plus 2d, and the last term will be a plus n minus 1 times d. This has to equal either 221 or 223. Now we can rewrite the left-hand side as the number of terms times the average of the first and last terms. We know that there are n terms, so we can state that n times the average of the first and last terms. So a plus n minus 1 times d all over 2. This is equal to 221 or 223. So it's worth remarking that the left-hand side looks like a product of two numbers. Now, if we look at the numbers on the right-hand side, we see that 223 happens to be prime. And 221, the only way we can write 221 is, other than 1 times itself, is 13 times 17. So more likely than not, the left-hand side should equal 221. But we can check this to make sure. So let's multiply both sides by 2 to get rid of the fractions. So I have n times, and then a plus a is 2a. So n times 2a plus n minus 1 times d has to equal 442 or 446. So we can actually show that 446 is impossible. And in order to show this, we know that 446 is 2 times 223. And because n cannot equal 2, n must equal 223. But obviously it's impossible to have 223 terms, positive integers, that sum to 223. So therefore the sum cannot equal 446 because the only possibility would be n equals 2, but we're given that n is at least 3. So therefore n times 2a plus n minus 1d in parentheses has to equal 442. And the prime factorization of 442 is 2 times 13 times 17. So n has to be a factor of 442 that is greater than or equal to 3. So the first thing that we can do is we can try n equals 13. The reason for trying this specific value is that 13 is the smallest factor of 442, which is not 1 or 2. So if we try n equals 13, then we're left with 2a plus 12d is equal to 2 times 17, which is 34. Now, if I divide both sides by 2, I will get a plus 60 is equal to 17. And we know that d has to be greater than 1. So we'll try d equals 2. This gives us a solution for a, which is 5. So we see that a, d, n can be the ordered triple 5, 2, and 13. So at this point, we can check that this ordered triple does indeed work. It is possible to check that 5 plus 7 plus 9 plus up to 29, which is equal to a plus n minus 1 times d. This is indeed equal to 221. Therefore, we don't really need to check any other values of n. We can just state that a plus d plus n is equal to 5 plus 2 plus 13, which is 20. Therefore, the answer is B.